What this is, and well, the only thing you see is a piece of silicon. This is actually a very first hologram on a wafer. With this specific chip, we want to actually show that we can use semiconductor technology to display an image. And the next step is to make this little tiny structure, which is today only hatched, to make them move. The basic concept is that we want to put patterns, and a pattern is basically composed of steps. And the step can have only two positions, so it's a binary step. And depending on where the step is, when the light is reflected, we are basically creating interference patterns. So we allow the waves of the reflected laser light to interfere constructively in order to create shades of color, or destructively in order to remove color, to make it black. This is all this is doing. And the pattern which is hatched on this wafer actually is an holographic pattern, so in this case it's calculated, and is such that it uses this interference, constructive and destructive, in order to create an object. Today we have basically two positions, let's say one for this, and the distance between the two is normally a quarter of the wavelength of the light that is used, so that it will change between red, green and blue. And the only way to make it move is to actually allow each of these pixels, how we call it, to do this movement, such that we can actually change the way the interference in space is executed, and that's all. Of course, by saying that's all is simplistic, because each of these pixels has to be half by half micron, and the movement is also in a matter of nanometers, and this is at the edge of what you can do with silicon germanium MEMS technology already. The MEMS structure is relatively simple. The control and the electronics, we are actually quite convinced that can be done, because something similar has already been done for other structures like memories. But the putting all together has to happen yet. At the very extreme, we need as many MEMS, a MEMS plate which is as big as the screen. There are ways to reduce the size, and this is what we're also exploring by changing the MEMS structures and use some sort of lenses. But let's say in the worst case it has to be a fairly large plate of MEMS. But they don't have to be one MEMS, they actually are tiled MEMS. So we could take one thing that actually we can already do here for images, so we have the technology already here, is to tile the MEMS in order to make a big screen. So the only reason why we are finding alternatives to try not to have a MEM plate which is as big as the screen, of course, is because of the cost of the final TV. We don't want to have a TV to cost 20,000 euros. We would like it to cost relatively less than that amount of money. Well, the beauty of it is that as long as 30% of them do what we expect them to do, so in theory we could calibrate it and remove 60% of them, we can still see the hologram. And this is not because of the technology we use, it's just the optical theory behind holographic projection. If you have 30% yield, which means 60% behave in a way you don't want and you have to remove them, you still see the hologram, it's just less bright.